Okay, guys. All right. Okay, for the benefit of those seeing from recording, today we're going to discuss the impossible integration question. Not very difficult, not moderately difficult, not complicated integration. It is impossible integration. So people who are here, listen to me. There are only two categories. Either they give you easy integration or they give you impossible integration. Impossible for all of us. Okay, why is there only easy and impossible integration? It's very clear cut because integration has no obvious rules to help you. In differentiation, after we discuss all the basic stuff, all the exceptions, I introduce you three rules. The three rules are how you manage complicated question. And therefore, they can give you complicated question, give you more marks. They demand more marks, they give you more marks, they demand that you are able to solve complicated one. What is the key? Only the three rules. The product rule, which is times, the quotient rule, which is the divide, and the inside rule, they call it chain rule. But integration don't have those rules. You gotta believe me right now. If I ask you to integrate something which has a times, you cannot do it. Not because you are not told, not because you are silly, not because you forget, not because I forget to teach you. Strictly speaking, nobody can integrate a times situation, a divide situation. Strictly speaking, nobody in this world. There is no rule that exists. In year 5, if you so wish to go to year 5, JC or JC1, you will learn what it means to deal with those things. If you do not wish to deal with that, poly is a very great idea. You miss nothing, okay? You miss nothing. All the integration and differentiation that you learn in Sec 4 is already very, very good for your university life. So poly to uni, man. For those who want to or feel that they have to go to JC1, take H2 math, or year 5, take HL math, understand this, even at that level, integrations are mostly impossible. Now let's go back to O level. Let's go back to our situation right now. Why do they give you impossible integration? Well, because they want to test your basics. Do you know that this is impossible? If you do not know that it is impossible, I'll show you later what it means to be impossible. If you do not know it's impossible, you will waste time. You will fret, you will try certain things, you will waste 5 minutes before you give up. The problem is not the 5 minutes. The problem is your morale is severely impacted. Oh no, maybe I just forget something. Oh no, this paper is going to be very difficult. Oh no, I cannot do an integration question. Oh no, it cost me 4 marks, another 4 marks, blah, blah, blah. But you just listen to me. Let me explain. But it is impossible. Then you will not waste time and you will not experience a drop of morale like that. Remember, guys, it's impossible. You're not supposed to even try. You're just supposed to identify, the impossible integration. Let me do what is useful. Today, I'm going to teach you what is the useful thing. The useful thing is not to try to integrate. The useful thing is to change the impossible integration to the easy integration. Straight like that. Pop, pop. How do you change something impossible to something easy? That is what we try to learn today in the first hour. In the second hour, I'll teach you some other skills which will also matter. Right? 1 hour is not a lot, so this just to give you a taste. Don't worry too much. This is the last thing they will teach you in class. Why do I teach you right now? Because they don't give you enough time to absorb that part. That I always notice that every time they teach you calculus, they give you all the basics, a lot of practices, and then come to exam, you're very confused about the exam question. What I'm teaching you is exactly directly applicable in exam situation. How to make something impossible to something easy. Possible integration to easy integration. As per usual, this is a new thing. I will teach a little bit and then I will ask you to ask questions. If we can, we make our own notes. If not, your questions are very valuable. Remember, ask from your blankness. Ask from, I don't understand something, I want to ask. That's what you need to do. If not, the session becomes way worse. Okay, any questions? If not, let's get on to it. Okay, let me show you something that most of you will remember from Sec 3. Maybe you forget how to do it, but this is a Sec 3 question. There is no additional knowledge from Sec 4. If you can do it, you can. If you cannot, cannot. This is 5 marks in this case, partial fraction. Okay, don't worry. I'm not going to put it heavily yet. Okay. Now look, they ask you to integrate this. Confirm one thing, this guy is exactly the same as the guy on top. There. Here's your 2x cubed, and this is your x squared minus 4. Let's just see below. There you go, your 2x cubed and your x minus. I can confirm that the rest are exactly the same. Now, people, hear me out very clearly. This thing is not a difficult integration. Let me repeat this one more time. This is not a difficult integration. Anu, what kind of integration is this? This is not a difficult integration. This is a what?
Easy integration.
It is not an easy integration also. No, it's not easy at all. I can confirm with you. It's not easy. It's not difficult. What is this, Anu? Is this? Come on. Come on, Anu. What is this?
Impossible.
Thank you. Anu and everybody else. This is impossible to integrate. What is the sign of an impossible integration? Very simple. If you have a divide, it is impossible. Later on, if you have a times, it is impossible. Needless to say, if you have square roots or whatever power is there, it is impossible to integrate. Impossible integration is like that one. An easy integration is very simple. Something plus something, something minus something. That's easy integration. Look at this guy. It is something, 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 divided by something, something, something. Impossible, that's it. That's all. That's it. Okay, let me emphasize this one more time. If I only take the top guy, there is no bottom guy, okay? I'm rewriting the top guy. Let's warm up a bit, okay? Okay, let's integrate. Ariel, let's integrate the first guy, okay? Informally, I will go up. Can you integrate the first guy, Ariel? Remember the 3 steps. First, write down what stays. Secondly, write down the power. Thirdly, write down whatever is attachment on the front. Ariel, unmute, please.
Is it 6x to the power of 4?
Okay, the 2x I agree, the power 4 I agree. What must you put here?
3?
No, 1 over.
Oh, okay, 1 over 4.
Yeah. Why is that so? A bit of memorization, but you just miss on the we call this, you miss on the third step. Okay, but why is this correct? This is therefore half x to the power 4. Why is this correct? If you differentiate, Eben, differentiate please. Write down what stays when you differentiate.
X.
Half and x. Half and x.
Half and
x. The power. Come on. Power. Wake up. Differentiation is -1. Power.
3, yeah, sorry.
3. And then the attachment in front. Attachment will be
4.
times 4. Okay, and this becomes 2x power 3. Now, Ariel, if you have any doubt there, your answer was 6x power 4, right? Now, 6x power 4 is wrong because this answer, when you differentiate, it does become the original one. Therefore, the 6th one must be wrong. Make sense? Okay. Ariel, would that be okay?
Yeah.
Okay. How do you know what is right or wrong? To be fair, yeah, if you have a pen and pencil, all you have to do is just test. It's so easy to test. I'm teaching you to test your integration and differentiation, not to memorize it only. Memorizing is never, a good pure strategy. Oh goodness. Never a good pure strategy. Right. So I'm just gonna, sorry. Okay, help me out here. Don't mess things up. Okay. Right, good. So let's continue.
Teacher, can you not
What?
erase that?
The top one doesn't matter. Then I'll rewrite it again. I accidentally erased just. Okay. Now, Kirana, integrate please. Remember the 3 steps. What stays? Power in front. What stays?
20x.
Don't forget the minus. Might as well, right? Minus lah. 20x. Power.
3.
What is in front?
1/3.
You may not know why, but this will be correct. How you differentiate, you're correct. Understand?
Yeah.
Okay, good. Integrate the next one, Nicholas. Come on, what stays?
So I was still writing.
Yeah, quickly, Nicholas, integrate.
Um,
What stays?
the 17
Minus 17x, right? Power?
power 0.
Oi, integrate, go up,
Power 2
right? And then times?
times 1/2.
Good. Nicholas, whatever it is that you're writing, yeah, it's not important as much as you can do this. Okay? You gotta believe that. So good for you. Last one, Anu, integrate this.
0.
That's differentiate. Differentiate this is 0. Integrate this. Whatever stays.
10
Mhm.
to the power of 1.
No, x to the power of 1. Because this is x power 0.
Oh, okay.
Okay?
Yeah.
And then for everybody else, I start teaching you this last week plus constant. You must assume that there's a number there. Okay? Now, even though this may feel like you're stunted, you're rusted, it's because you lack practice, and I do not give you practice. Not at all. This is considered the easy integration. Why do I declare at the start that this is impossible? Because very simple. It's the top guy divided by the bottom guy. The moment you see a division, impossible. Do not integrate. Do not even try. Do not even worry. Do not even fret. All waste of time and energy. It's impossible to integrate what you are seeing in front of you. Being able to do this does not help at all. Let me do this one more time. This does not help you at all in this impossible situation. You got to believe me here. It does not help at all. Either the question gives you just the top one and therefore easy to integrate, or if they give you top and bottom divided, do not even do this. It does not help in any way. I tell you this from the start. I need some thumbs up. Even though you do not understand, your thumbs up means at least you're hearing me say those words. Nicholas? Do you understand what I'm saying?
It's impossible. You're saying that I shouldn't even write it.
Shouldn't even write this. It's a big temptation. Do not write this at all. It is useless to the nth degree. Useless. There is something else that you must do. Now, if you don't get this, people, you will never be able to do the impossible integration freely and fastly. It's one of the easier ones, actually. Once you realize it's impossible. Okay? Once you realize. So, I will erase all this. So for those of you who are writing this, it's not that your writing is useless. It's good for warm-up. For this question, however, it is totally useless. Totally useless. Okay, let me repeat one more time. Now, at the risk of saying the obvious, let's say I take the bottom one only. Let's say I change the question, right? Okay, make it easier lah. Now, can I integrate this or not? Of course, whoever is answering this question, you do not know clearly. This is the first time you see this kind of question. I'm still asking you, Ariel, is this easy integration or impossible integration?
Oh, wait, like the thing right at the bottom.
Yeah, just integrating the bottom one, I'm changing the question. Easy or impossible?
I think you can expand it and then it becomes like easy.
Wonderful thought, Ariel. This is therefore what Ariel is saying. This is impossible. Don't even try, but try something else. Try changing it. What Ariel is saying is if you expand, right? How many rainbows, Ariel?
4.
Right? You do it for us, please.
Oh, okay.
Tell us, what is it? First rainbow?
Wait, sorry. 2x to the power of 4.
Good. Second rainbow.
Wait, what? Why would you do that? Never mind.
That's fine. That's fine. Just follow.
Okay. Minus 6x to the power of 2. Wait, what? Oh, I mean 8. Sorry.
Minus x to the power of 2. Good. And then the next one will be this one.
Minus 4.
And then the last one will be this one.
2x to the power of 4.
The last
Wait,
one.
is it? What's the last one? Oh, sorry. X to the power of 2.
Right. And yeah, I can simplify this into minus 7x squared, right?
Mhm.
Ariel's idea is on point. Now, this is easy. This is easy to integrate because it's just plus and minus. This is impossible. Change it to easy. They will train this rather early at the start, right? But I want to emphasize there's only 2 classes. Impossible, easy. Impossible, easy. Now, here's a question for everybody. Eben will help us answer. Eben, you know that you can integrate this. This is quite easy, correct or not? Now you can. Correct, Eben?
Yeah.
But if I now revert the question, now the question is this full thing lah. This is full thing lah. This divide by that. Is this useful to do or not?
No.
You must believe me when I say yes, it's totally useless to do. The ones that we did just now for the top guy, totally useless. The ones that we're doing right now for the bottom guy, totally useless. If you do this, you're not just wasting your time, you're wasting your morale in exam. That's the more dangerous thing. Okay? Again, whether you... Yes, Eben, you want to ask?
No, nothing. Yeah.
Again, even though you may not be able to accept this 100%, but I need you to thumbs up if you hear what I say. Good. Kirana and Nicholas, do you have any? Okay. Nicholas, do you have any? Okay, good. Remember, one more time, this is useless. Even though if it is just this guy, Ariel has a very good idea. Now you have an idea on how they make it very difficult. What am I supposed to change this with? What changes can I do in order to make this from impossible to easy? Well, they already tell you. This question is very kind. 5 marks for partial fraction, and the partial fraction itself will set it almost straight. They did tell you you need result from part 1, which is partial fraction, and part 2, whatever that is. They need these 2 in order to make it possible. One more time. This is they telling you, yo people, that is how to make it from impossible to easy. So you don't even have to think, you just have to do. I'm not interested in reviewing partial fraction today. I'm just going to copy the answer. Where is it? Let's just look at it. This question 6 again. There you go. Not interested in how to doing partial fraction. You should have an idea that, yeah, okay, my partial fraction better be good lah. True, but that's a matter for different. Okay, I'm copying the result. Putting it there. Go back to the question. Okay, now by right people, this is easy. Oh, we are supposed to be able to integrate is going up. Now, the syllabus will have an attitude like this, okay? Hey, I've already helped you change from impossible to easy, okay? I give you the impossible thing. I help you to change it. So I expect you to be able to do this because it's easy, right? Not really so for us lah. What the heck is this guy? How am I supposed to integrate this guy, right? Still not very helpful. That is what we're trying to learn today. We're trying to learn the supposedly easy integration part. Okay, oh my goodness, this is supposed to be easier. Now, let me show you the hint. No matter what, if it is easy, I must be able to help you from differentiation. Let me repeat this one more time. Your thinking must be like that. Oh, I remember what teacher Philip said. This is supposed to be easy to integrate because I have my partial fraction. But I heck don't know what's going on. What you must do, people, when it is supposed to be easy, is to just remember some sort of useful differentiation. You must remember the differentiation which you can reverse. One more time, huh? Or your differentiation is either the normal one or the exception one. I'm gonna revise with you the exception. There are only 3 exceptions. The cosine one, sine 1, which is useless here, right? Useless here, not this guy. The e power x, which is useless here, right? One more time. There is one more exception. There's one more exception. Now, what would that be? Does anybody remember? Kirana? Remember the last exception.
Is it ln?
All right. Differentiation of ln x is?
Is it the same?
No. This one is the same one. Only this one. This one, it doesn't make sense, okay? So just to remind everybody lah, or 1 over x. Okay? You should have some sort of recollection or memory from this one. Now, I claim to you, people, look, this is what we need, people. People, we need it for this guy. That's my claim. They look superficially similar. Okay, they look superficially similar. So one more time. Let me remind you. The integration of 1 over x, I'm just writing it formally. This is the way to formally write down, is equal to ln x. Don't forget the plus c. This is what is happening right now. I need you to thumbs up if you can accept this. Okay. If not, please ask questions, right? Because I'm going to use it immediately. Ariel and Nicholas? Ariel, Nicholas, are you okay?
So reading it.
Ariel, are you okay? Okay, I'm going to proceed. Now, listen to my claim. Look, the number 3 never matters 1. All the numbers in front never matter 1. Okay? You see 2 sine x. I want to integrate the 2. The 2 doesn't matter. The 2 just leave it there and just put it back. Okay? So now, don't trouble yourself with this 3. Do not trouble yourself with this 3. Just treat it as, okay? Just treat it as something that looks easier. In fact, the minus also does not matter at all. Frankly speaking, the minus doesn't matter. Treat this as minus 3, 1 over x minus 2. And focus your attention on this guy. The minus 3 does not matter. Okay? Now, informally, arrow up means integrate. So again, the minus 3 doesn't matter, right? The minus 3 doesn't matter. This guy now start to look a lot like 1 over x. The difference is minus 2 lah, right? The difference is minus 2. Is there any brave soul who want to make a guess? I'm inviting people to guess here. One brave soul, please. Make a guess. The integration of 1 over x minus 2. Okay, I am just going to make the guess. I'm going to say that, oh, that guy is logarithm natural x minus 2. Okay, that is my claim. My claim is it becomes that, the integration, based on this lah, based on this guy, okay, based on that guy, okay, same thing, okay, based on this guy. Okay, now, how do we know that I am correct? Okay, how do you know I'm correct? There's too many memorization. It's better to test it out. So we test it out by differentiating lah. Minus 3 doesn't matter, right? 3 doesn't matter. The differentiation of logarithm natural x minus 2. There is an insight here, correct? So I need the chain rule. Okay. What do I do with the chain rule? I pretend that everything is normal. Remember, my guideline is logarithm x, logarithm natural x, 1 over x, integrate. Now, to differentiate, my guideline is I look at this, I look at that. Oh, okay. I'm going to do this one first. Minus 2. Okay, and then I'm going to differentiate the inside. I'm just going to put number 1. As a result, I do get my minus 3 over x minus 2. And I am back to the original. Okay, this is the first time you see such a weird integration. If you get it, good for you. If not, please ask. Please clarify. Okay. Okay. Eben, are you okay now?
Yeah.
Sure, yeah?
Okay.
Okay. As much as you can, of course, yeah? Kirana, are you okay?
Yeah, I just need to take time to process it.
Of course. I'm going to repeat this one more time, and then I'm going to ask you to integrate this one. Everybody, yeah? The second guy is super similar to the first guy. Whatever you do to the first guy, you can do to the second guy, right? I'm going to erase this one more time. Nicholas, do this with us. Nicholas, we're going to integrate this one. I'm going to help you. Nicholas, what do we do with the minus and 3?
Make it minus 3 bracket 1 x minus 2.
You think about it for a while. Is that good for you or not? Is that nice?
Okay.
Okay. Then if you're ready, you integrate lah. So what do you do? Tell me.
Minus 3
outside doesn't matter. Then
ln x minus 2.
ln x minus 2. And then I'm telling you this is a guess. Remember, integration are always guesswork. How do you confirm? You differentiate. Help us, Nicholas, by differentiating this. Differentiate. Minus 3 doesn't matter, right? So what do we do? There's a here, right? Okay.
Inside.
Your guide is this one, right? So what do you do?
ln x 1.
If the differentiation of logarithm natural x is 1 over x, what is the differentiation of logarithm natural x minus 2? Come on. Okay. Logarithm natural x minus 2. Logarithm natural x becomes 1 over x. So what you must write, Nicholas, is 1 over what?
1 over x minus
2. Correct.
Let it.
Because logarithm natural x becomes 1 over x. Logarithm natural x minus 2 becomes 1 over x minus 2.
There's no in between.
with the inside differentiated 1. This is your chain rule, right? It's your chain rule. You have to use your chain rule here. Because the inside complicates things. When the inside complicates things, we chain rule. Simple, right? Settle the problem.
Yes.
Slowly but surely, I hope you're absorbing this. People, one more time, when I teach you to integrate, I immediately differentiate. Not to convince you, not to confuse you. Sorry, not to confuse you. Not even to convince you sometimes. Sometimes you will feel that what is going on. But I want you to be able to do both without being confused. You have to be able to do that. If not, your integration will be mixed with your differentiation, and that's a bad thing. Okay, this is my effort to make it exist side by side in your mind. You have to be able to do this. If there's no more question, people, everybody, I'll give you 2 minutes to do the second one. Okay. I am going to erase this, by the way. I am. So 2 minutes to do the second one, please. Ariel, you're going to give a guess for us, yeah? After 2 minutes.
Wait, teacher,
Yeah.
what are we supposed to?
Nicholas, your response is very... So yeah, you're supposed to integrate the middle guy. Yeah, 44 minutes. 44 seconds.
Oh,
Okay, Ariel, what do we do? Let's integrate the second guy.
Or I don't know.
Don't say you don't know. That's your favorite thing. Do something.
Wait, I really don't know what to do.
What do you mean? What's the first thing that we do in the first guy?
Uh, I have no clue.
Ariel, what is the first thing? Remember, what is the first thing that we do for the first guy?
I really, really don't know.
Ariel, I'm already giving you too many hints. Steady yourself and remember. What do we do with the minus and the 3? Listen to me, Ariel, yeah? You cannot do this all the time, yeah? Listen to me carefully and focus. The minus and the 3, does it matter for integration or not?
No.
Then what do you do to help yourself?
Move it.
I expect you to do this for the second guy, please.
Okay.
Say it out.
So I just put 2. Draw the bracket. 1 over x plus 2.
Ariel and everybody else, look at this first step. Is this useful or not? As in to your brain, to your mind. Does it calm you down? Does it make you feel it's gonna be easier? Those kind of things. What do you think, Ariel? Does it make it feel better? Does it make you, oh, this is gonna be something easier now?
Not really, but yeah.
Then Ariel, I'm gonna help you one more time. This is the clue, the only clue. The integration of 1 over x is logarithm natural x. The differentiation is that area. Okay? This guy
Okay.
that you are paying attention to, who is it similar to? This guy or this guy?
The one at the bottom.
Right. And we are supposed to integrate this, right? Because, you know, the question asks us to integrate. Correct? We are supposed to integrate. So we start from the bottom guy, which is very similar to what we're dealing with. Is that a good news or bad news?
Good.
Then integrate lah. Okay, first thing first, what is the 2? The 2 doesn't matter, right? Just write down like that.
Yeah.
So integrate, please. Integration is basically making a guess based on the basic stuff. So make a guess. That's all I ask.
Okay.
Come on, guess
Ln x plus 2.
with a nice bracket. And immediately, what do you do to confirm your guess?
Differentiate.
And you have to worry about the inside, which means you need a chain rule, correct? So
Yeah.
differentiate, please. Does the 2 matter?
No.
The 2 doesn't matter, so you write down the 2.
Okay.
Differentiate.
1 over x.
No. This is
No.
the inside is x plus 2.
Oh,
Come on,
okay.
focus.
1 over x plus 2.
And then to handle the chain rule, you must differentiate that inside and then put it in front, correct?
Yes.
What's the differentiation of that inside?
Well, like what's the differentiation of 1 over x plus 2?
No, what's the differentiation of x plus 2? Only the inside.
Wait.
What is the differentiation of 2?
0?
Good. What's the differentiation of x?
Wait.
What is the differentiation of 4x? Ariel, what is the differentiation of 4x?
I don't know. Wait, let me check my notes.
Quickly, you have 1 minute. Ariel, are you ready?
No, can someone else do it?
Eben, differentiation of 4x?
4,
Differentiation of x?
1,
Ariel, what is the differentiation of 4x?
4?
And what is the differentiation of x?
1?
Thank you. That is the chain rule. I know the 1 doesn't seem to matter, but if you cannot even do that, it will wreak havoc to your confidence. Right? And we have finished confirming our integration with the differentiation. The integration is not a pure guess, it's an educated guess. And the differentiation kind of confirms it. Both are very difficult to do, I understand. Okay, I understand that. One more time, One more time, people. I keep saying that this is supposed to be easy. I understand that this is very weird and very difficult to accept. Okay, the easy thing is not easy, right? But there are a few things that you can take lah. That means if I say it's impossible, whether you think of it as very hard or impossible, really impossible, you believe me lah, it is actually impossible. You're not supposed to try that. Okay, you're not supposed to try the impossible thing. You're supposed to start from the easy level, which happens to feel very weird. That's why we're talking about it today. Okay, that's why. Imagine having to accept this when you have to learn all the other subjects and I don't know whatever else. SA1 is coming, whatever. A lot of too much pressure. Too much pressure. We're learning the weird stuff right now. Okay, right now. Yeah. So be courageous and stay with me for another 10 minutes. Okay. Let me confirm this that there is no question lah, I suppose. You can ask questions. Okay. Now, this is supposed to be easy, supposedly. Supposedly, yeah. This is supposed to be easy, supposedly. Now, let's talk about this one. I didn't teach you from the start. Okay, this is easy. No, that's not what I teach you. I teach you to identify whether something is easy or impossible. The one, right? Kirana, the last guy. Is it easy or is it impossible? Which one?
They say can use like the same method as just now.
Okay. So all you're saying is that this is supposed to be easy, right?
Hopefully.
Hopefully. Now, the identification is the most important thing. So I have one vote here. I have one vote. You do notice that it is a slightly different, but okay, you say, okay, okay, now let's do a vote. Okay, you don't know what's going on, but try your best lah. Yes. Nicholas, before you go, this is easy or this is impossible?
I think it's easy.
Okay, 2. The rest, please don't start thinking when I call your name. Start thinking right now lah. Anu.
Easy.
Ariel.
Easy.
Eben, last one.
Easy.
Okay. Now, of course, you don't know, right? You're just guessing. But all of you are totally wrong. This is impossible. Why? I told you before. When you see a division, it's impossible. Now, let's get this clear. Why don't we consider this not a division? This is not a division. I know it's a fraction. Well, look. It's 1 over x minus 2. 1 over the 1. You have this guy to help you. 1 over x. See, this is basic integration differentiation. 1 over x. 1 over x minus 2, not a lot of difference. Second guy, same thing. Not a lot of difference. The inside, not a lot of difference. Easy. This guy, however. I mean, is there anything you can do to get rid of the x on top? Anu, is there anything you can do to get rid of the x on top?
What? Can't we bring it down?
Okay, let's see. Okay, I have to convince you not to ask you to memorize. I have to convince you, everybody, that this is impossible. If I fail to do that, it's not a waste of time, but that's the struggle here. The struggle is not even in the integration. The struggle is every one of you think this is easy, and therefore you will try, and therefore you will fail. That's bad. Tell me, Anu, what's your idea about handling the 4x? Bring it down. What does that mean?
Like 4x and then bracket 1 over
2x
Okay,
squared.
right. Which is the same thing, right? Okay, I'm gonna do this way, right? Okay. And now this is easier to handle. Yeah, the problem is now this looks like a time, right? With an x. The problem is people, you must understand the problem. The problem is no matter what, this contains an x. Whereas this one, there is no x. It's just a number. This is just a number. No x. This is a number. No x. There's no x here. This one, there is an x. The x is the problem. The 4 is not. I agree. The x is the problem. Whenever there is a x times whatever with an x, we have an impossible situation. So now let me clarify for you. This is x something something something, and this is x something something something. Or this is x something something something. Sorry, yes. Wait, stop messing it. X something something something, x something something, x something something. The x tells you this is going to be impossible. Nothing can be done. We must change it. That's what I'm trying to say. Anu, can you kind of accept that?
Yes.
Ariel, Eben, Kirana, Nicholas. This is the reason why it is impossible. Can you accept that? Maybe a thumbs up would be nice. Or clarify lah, Ariel. Yes, Nicholas.
Can you repeat why having an x will make it,
The why I never explained. Actually, I didn't even aim to explain that. Too complicated. This is the case where if I try to explain, it'll take too much time.
Is it because 4x just cannot work with an ln?
Something like that. The times makes it impossible. You can no longer compare this. Can no longer compare this with the basic one. Cannot.
So without x is okay, but
With
so
x,
there's nothing wrong with the x square. It's just the x.
no. I'll show you later why the x square is actually okay. The x on top makes it impossible. Just like that. It's really just like that. If you can accept that, because I never claim to explain to you, but if you can accept that, that is the most important skill. If not, again, one more time, you will try, then you probably think you will succeed, whereas you are just wasting your time. This is impossible. It is a good question, Nicholas. Now, might as well ask you, Nicholas, look, if this is impossible, what are we supposed to do? We're not supposed to try to integrate it, but what are we supposed to do? Nicholas? Okay, we have 5 minutes, yeah? I'm going to demonstrate. I hope I have done some effort in convincing you this is impossible. What are you supposed to do? Now, let's check out this guy. The question maker knows it's impossible. It's not very hard. It's not complicated. It's impossible. The job or the responsibility of the question maker is to help you because they already know this is impossible. In fact, they already help you. You might be the one who think it's easy or doable, and therefore you try to do. And therefore you sabotage yourself. So I've given you one hint. The X is the problem. The question maker itself gives you another hint. The question maker actually always try to tell you one, hey bro, it's impossible. See, I try to help you. You must get their hint lah if you don't get what I'm saying. Right? There are two ways to do it lah. Take their hint, take my hint, whichever. Okay, now let's do this first. Differentiating this is supposed to be very easy because it's differentiation, it's not integration, the weird guy. So Anu, please differentiate this for us with the guideline of logarithm natural x becomes 1 over x. Come, Anu.
1 over 2x squared plus 1.
But there's an insight, right? Don't forget. So we must do the chain rule, which is to say you must times in front the differentiated result. What is it?
Um,
Differentiation of 1 is 0, correct? What is the differentiation of 2x squared?
uh, 2x to the power of 1
Times,
times 1.
no, times 2, times
Or
2.
times 2, yeah.
Okay, y memorization. So 4x, correct? 4x, right? Now, if I write this down, this is 4x over 2x squared plus 1. And this is 2 marks. 2 marks, easy 2 marks, okay? The differentiation not there. Okay? Everybody who understand the differentiation and are okay with it, please thumbs up. If not, ask. Come on. Okay, good, Ariel.
Oh, wait, I got
Yes,
a
Kirana.
question.
Yes, Kirana. Go
Wait,
ahead.
why got the 1 over the 2x squared plus 1 again?
Because when I differentiate this, I must compare it with something, right? I must compare it with my basic stuff, lah, correct?
Oh,
This is my basic exception, and I realize, hey, they are comparable. I start to do it like that. That is the basic of complicated differentiation. Understand?
okay.
Comparing it with the basic. A good question.
Okay.
Anybody else? Now, people, look at this. Look at their hint. I claim that they give you a hint and you should take it. Look, like is this like a coincidence? Part 2 gives you a result which looks exactly the same as what you're supposed to do in part 3, which is supposed to be impossible. Is this a coincidence or not? Cannot be what? Look, there's an X on top. Look, the 4 is there. Look. This cannot be a coincidence. By hook or by crook, people, you either get what I'm saying is impossible or you get their hint. See, they're trying to help you. It must be impossible. You must use their hint. If not, you cannot do it. Okay, so one more time, one more time. Now, let me just make it very clear what their hint is to you. Their hint is they give you this guy out of nowhere, give you 2 marks to differentiate. The result is this. Right? That's the result. And then in part 3, you realize integrating this one is impossible. Look, what is the integration of this guy? At the risk of being obvious, Eben, would you please help us? What is the integration of 4x divided by 2x squared plus 1?
That thing, the same ln
Ln,
2x squared plus 1.
do you understand, people? The integration of this guy is therefore logarithm natural 2x squared plus 1, which, let me repeat this one more time, is not doable at all using the thing right now, even though it looks similar. I guarantee you that first. They have to help you. You take their help. Consider this impossible. Do it with their hint. This is the most important thing I'm trying to tell you today. That's how you treat impossible things. You take their hint. Easy things, you have to do yourself. Okay, Nicholas has to go already. We have to take a break. Can you at least thumbs up if you kind of can accept this? Okay, good. Okay, Nicholas, you won't miss much. If you want to review the recording, that's fine. Everybody else, let's take a 5-minute break.
Oh wait, Teacher Phillips.
Yes, go ahead.
Do you have
Bye.
do you practice questions for differentiation and integration?
Right. Now, today, after today's session, you will stay, and I want to see a little bit of your practice book first, because if it is not suitable, I will immediately tell you what to do. Can, Ariel?
Okay. But
Very good.
do you have questions like now though?
No, for 5 minutes,
Okay.
no point. Okay, 5 minutes, no point one, no point. Okay?
Okay.
After this, maybe. See you later. Hmm. 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 Okay, Anu and Ariel, are you back?
Yes, I'm here.
Okay, Anu.
Yeah.
Very good. Anu.
Yes. Yeah.
I promise to answer your question later, yeah, after the next one. Eben and Kirana, are you here?
Yeah.
Okay, Kirana. Eben? Okay, we'll still start, yeah. For those watching from recording, remember, all I'm trying to show you today is why certain things are easy. That means you do yourself. It doesn't mean actually that it's easy, right? It can still be very confusing. Or why certain things are impossible. You shouldn't try it, even though you will be tempted. It's super weird one, people. The easy one, you don't feel like doing. Feels very weird. The impossible one, you feel like doing it. This part is so counter to our instinct. That's why I'm making a big deal out of it. Your instinct is working against you. This is easy, man. Do it. I'm very confused. This is impossible, man. No, I don't believe you, teacher. I think I can do it. Okay, and we just keep fighting. Now imagine doing that inside the school days when you're supposed to study many things and exam is coming. It's not fun at all. That's why we cover it today. Now, you may not get it fully, but notice a few things. Notice that partial fraction result will always look like this one. They know that partial fraction is meant to make something impossible easy to integrate. So therefore, you will always deal with this. I call it a good news because in the end, with practice, it will be doable. With practice, it is very predictable. A lot of marks, probably not 10 marks like here, like this is 5 plus 5, okay? Probably more like 7 to 8, still a lot. It always happens after a while, you will get it one. But sometimes school forget to give you enough time to digest. So then in exam, you panic. This is not supposed to be that difficult after you get used to it and you do have time. To answer your question, Ariel, with everybody else, the practice will not be from something easy in your textbook into something more difficult like this. The practice is immediately this. There is no other thing. If you don't practice from prelim question for this particular thing, you don't get it one. You don't get why this is easy. You don't get why this is impossible. You don't get why we do certain things. This is a very specific question that they always ask, and you have to practice exactly like this. for this one. Do you understand, Ariel?
Yeah.
No books, immediately the prelim. I, however, promise you, it is very predictable after a while. Okay? No matter how much you want to complain, no matter how much your instinct resists it, you must admit after a while, hey, it's just like that one. That's the good news. Okay? Doesn't feel like that this 1 hour. I get it. But that's why I start earlier. Now, I am not interested in teaching you more impossible ones for now. Okay? Not yet. We have to do something more important. Now listen to me. Listen to me for, okay? I'm not continuing on the impossible integration, right? Again, impossible integration, change to make it easy. I show you the partial fraction one. That's one group. And I promise you, the practice will be predictable. I promise you. So there you go. Done. The second group I'm not teaching you is actually, that's the easiest one. Just believe me, there's another group of impossible integration, which is supposed to be the easiest one to understand. And then there's the third one, the most troublesome one. The most troublesome one is when they combine trigonometry with integration, not trigonometry with differentiation. Trigonometry with differentiation, totally doable. You can do it. Just need practice. Trigonometry with integration, it messes you up in a totally different way. The first group, the one that we covered just now, messes you with your instinct. When it is supposed to be easy, you feel that it's very complicated. When it is supposed to be impossible, you feel that you can do it. Kind of just totally mess you up instinctively. This one messes you up because you have to deal with trigonometry and you have to deal with integration. Both are very weird subjects. Now, trigo. I keep asking you guys, hey, trigo, how's your trigo? So 50 marks for the differentiation integration. That's a lot of marks. 30 marks for just trigo. Also a lot of marks. In total, they're around actually 85 lah. So 50 plus and 30 plus. 85 marks. 85 marks is more than half. Almost half of your exam. Just from differentiation, integration, and trigo. No matter how much you hate trigo, no matter how much trigo doesn't agree with you, we have to deal with it. Today, I'm going to start by dealing with the most troublesome part. We will not have time to go into trigo plus integration, but you believe me, if you cannot handle this troublesome part, not just your trigo integration is in problem. Actually, small marks doesn't care. Your whole trigo is in problem, and you don't want that. Ariel, you know what it's like already. Your school crazy enough to just rush through everything, correct? Crazy enough. Correct.
Yeah.
We do not want that feeling entering Sec 4. We are going to deal with the most important one. For the rest of you are normal. Your school either haven't started or just a little bit. We are still going to deal with the most important part. Okay, enough lecture. I will show you what it means. Ariel, this one, hopefully you'll find it less weird than the integration differentiation just now, right? Great. Now, look at the start of the question, you will have this list. They call it identities. Identities simply mean it is always correct. Okay? Yes, Anu, what we are trying to do is to make you able to use it in the most difficult part. Okay? Now, if you can do that, this 1 hour will be a waste of time. I'm guessing that it is not going to be a waste of time. So you follow me. I'm not trying to explain the identities. I'm not trying to use the identities. I'm preparing it for usage. One more time, people. I'm not interested in discussing questions. I am preparing this to be usable for you. Because even if it is in the exam paper, even if it is not memorizable, I still find you guys very uncomfortable with this thing. Very, very uncomfortable. So we have to make ourselves comfortable. That's the goal for the, I guess, 45 minutes. Now, Eben, you'll be struggling the most lah. You have seen this, but you have not used this before, correct?
Yeah.
Eben, hear me out. We are trying to memorize this in the best way, in the easiest way, in the least weird way. So it doesn't matter whether you understand or not. It doesn't matter. Or it doesn't matter too much. You're going to follow us. You're going to memorize this. And when your teacher start using it, you will immediately feel comfortable. If we don't do this, you will always feel uncomfortable. That's just how people react to trigonometry. Eben, can you give me your benefit of doubt for now? Okay?
Okay.
Same thing with you, Kirana. We are not trying to use it. We're trying to make it as comfortable as possible. So you follow. Okay. Now, my goal is, people, not to ask you to memorize, but the end result is you have this in your mind, which is the same thing as you memorize it lah. But you memorize it in a way that is very nice. So it's very different from memorization. It is preparing it for use. This is, to most of you, are totally useless because you don't feel comfortable. One more time. At the end of 45 minutes, I hope you guys are ready to use it. Your teacher will just ask you to use it, and you can. The question demands you to use it, and you can. Okay? You don't have to question why this is correct. If you press in your calculator, sine 41 degree, a very ugly number, plus, or with the square, with cosine square, 41 degree, also a very ugly number, it will give you 1. So the angle doesn't matter as long as this is the same angle as that one. If this is 41 and this is 39, obviously it does not work. It has to be, well, in this case, 39 or 39, whatever. 305, 305. The numbers doesn't matter. Now, we're going to memorize this by using a very informal form. Now, this is how you're supposed to present in exam. We don't care about that at all. Presentation is often not the best way to memorize. Presentation is often not the best way to get it in our mind. In our mind, you want it to be fast and you want it to be flexible. This is the two requirements so that you can use it effectively. You want fast and you want flexible, we need some sort of informal shortcut. That's why I keep showing shortcut to you guys. You have to think in terms of shortcut. If you think like this and you write like this, you're going to be very rigid. You're going to be very slow, useless. Very wonderful brain, cannot use. Now, the shortcut for sine square A plus cosine square A equals to 1 is simply like that. And then we are done. Okay? In 2 seconds or 3 seconds. Anu, Ariel, Eben, Kirana, take your iPad and pen and immediately write this. Please tell me when you're done. Okay, good. Now, people, I would like to remind you a few things. This one is a reminder. They expect you to know this. We will forget, so sine over cosine. Okay, the formal way to write down is sine A over cosine A equals to tangent A. You may not know why this is correct, but it is correct. I don't care about the formalities. You should write down as sine over cosine equals to tangent. So please write that down. Cosine over sine equals to cotangent. Why is that so? They just anyhow name it lah. Cosine over sine is cotangent, no? 1 over sine, they call it cosecant. 1 over cosine, they call it secant. Before we proceed, you have to know these 4 things. So this and that. You have 10 seconds to write this, and then I'm going to erase it. You're going to erase it. We're going to repeat it to ourselves. If you have a question, please ask. Yeah? But other than that, this is memorizing in a useful way. So, okay, I hope you're ready. I'm going to erase this. People, erase your writing. They are not useful. It's for memorization. Erase it, please. Now, when you're done erasing, please thumbs up. Erase your own writing. Good, good. Eben and Anu? Anu, have you erased? Yeah, good. Now, write this down. Very easy. Tangent. Cosine over sine equals to cotangent. If you feel like it, say it out, right? 1 over sine is cosecant. Don't know why 1 over cosine is secant. Write down this very fast. Right.
Sorry.
Yes, Evan?
What? You wrote C over S equal.
Okay.
What's that?
This is formally cosine A over sine A
Yeah.
equals to cotangent.
Oh.
Not like cotangent, whatever that
Okay.
is, cotangent A. But right?
Okay.
Okay. You'll see a cotangent here like that. There you go. Okay. Okay, I hope you guys are done. Now, again, we keep erasing and we keep writing. What else do we do but to memorize? That's how we do it. So everybody, we are going to erase our own writing and you are going to rewrite it yourself. Go, I'll give you 30 seconds to write. Okay, shouldn't take long. Go. I can't even do 30 seconds. There you have extra, more than 30 seconds. Go. Erase, rewrite, erase, rewrite. Those who are watching the recording, don't watch it. This is supposed to be where you do things. Okay, whether you're right or whether you're wrong, it shouldn't be slow. It should be fast and flexible. Later you'll see what flexible means. Now just check your working. You're supposed to, I am so sorry. You're supposed to write this. You're supposed to write this. I am so sorry, see wrong again. Sine over cosine equals tangent. Cosine over sine equals to cotangent. 1 over sine equals to cosecant. And 1 over cosine equals to secant. I know you get all correct.
Yeah.
Good, Ariel?
Yeah.
Good, Evan?
Yeah.
Good, Kirana?
Yeah.
There isn't much to memorization, people. Just don't read. Just do. Just rewrite. When you want to recall, you write. We'll keep doing this, and soon you will feel comfortable. You don't know why. It's not that you understand, but it's that you have it in your mind. You have accepted it. That's the goal. Okay? Now, let's talk about the second guy here. What I am explaining to you, some people will say, what's the point? It is already here. What do I mean? I am trying to explain that the first guy, the second guy comes from the first guy. In fact, the third guy also comes from the first guy. Some people will say, but what's the point? I can just see it from the paper. Well, the point is to help you accept. That's the first point. The second point is the questions in exam will exploit this connection. Some people simply miss them because they do not know. The second guy comes from the first guy. The third guy comes from the first guy. Okay, so let's check it out. Let's check it out, the connection. Look, back to this guy, yeah? Idoldor, and for some reason, Idoldor divided by cosine square. That's what I want to do. I have sine square over cosine square plus cosine square over cosine square equals to 1 over cosine square. Now, Anu, what is sine over cosine?
Tangent.
Therefore, sine square over cosine square is?
Tangent square.
Which you will notice is this guy. Okay, and then cosine square over cosine square?
1.
1. Oh, sorry, this is a plus. 1. And then 1 over cosine is just now?
Cosecant.
No, secant.
No, secant.
A bit memorization. It's okay. Okay. Secant square because of the square. Do you notice I have just discovered the second guy? Look at that. Anu, are you okay?
Yeah.
Second guy. The second guy is connected to the first guy. That's my impression to you. I'm not asking you to oh wow, I have to memorize the connection. I am. But the point is to help you feel good about it. Ariel, Eben, Kirana, can you see what I'm trying to do?
Yeah.
Okay. Now, I'm going to try to find the third guy from the first guy also. And I'm going to do a door also. And then door will be divided by sine square. Ariel, sine square over sine square. Okay. Plus cosine square over sine square. Okay. Plus 1 over sine square. So far, so good?
Yeah.
Now, Ariel, what is sine square over sine square?
Uh, 1.
Very good. What is, to help you, cosine over sine? Yes, huh?
Cot.
Cot, whatever that is. So cosine square over sine square is?
Cot.
Ariel, focus.
Square.
Very good.
Squared.
Thank you. Now, what is 1 over sine?
Cosecant. Something.
Right, whatever that is, right? But you're correct. So 1 over sine square is?
Cosecant squared.
1 over. I'm sorry.
Oh,
I'm sorry.
1.
No.
Oh, yeah. Oh,
You're
okay.
correct. You're correct. Of course, you're correct. Cosecant square. There's no 1 over. Now, I have, Ariel, if you notice, I have discovered the third guy. There. Would that be okay? That's the third guy.
Yeah.
Okay, the order is a bit different. Who cares? It's the same thing. Now, people, thank you for your help. People, what are you going to do? Very simple. I put an emphasis on the relationship because it seems to give our brain a good feel. It feels like, okay, good, they're connected. They're not disparate. They're not separate. They're not they're not as weird as I think. Maybe I'll put it that way. Maybe that's why you feel good. So people, now follow me. We're going to write down very fast. Feel the same thing for the first one. Tuck, door divided by, up to you, 1 the sine square or cosine square, doesn't matter. This will be immediately in your mind. Sine square divided by sine square, 1. Plus cosine divided by sine, cotangent, don't forget the square. 1 over sine is cosecant square. Immediately you do that. From 1 to the third one, door divided by cosine. Sine divided by cosine, is tangent square. Cosine square divided by cosine square, 1. 1 over cosine, what do you call it? Secant square. And then we are done. If you can do this, if you can write down these 3, please thumbs up. I'm going to erase it very soon. Good, Anu. Good, Ariel. Yes, Evan.
What does door mean?
Okay, Eben, because we never talk about it in your amath. Okay, for a refresher to everybody, door means whatever you do to the left, you must do to the right. This is the basic rule of algebra. If you have an equation, there is a left and there's a right. Whatever you do to the left, you must do to the right. Does this sound alien or does this sound like it makes sense, Evan?
Yeah. Sounds.
Okay. Teacher just don't say door, but I hope you will remember from now on. All door simply means whatever you do to the left, you do to the right. Helps a lot. Okay, people, erase your working and let's do it one more time. I'll give you a bit delay, then I will start working. Go.
Yeah, just now I was a bit confused with the second.
Right, Kirana, follow me. Follow me, and I'm going quick. Are you done, Kirana? Okay, now the first one is divided by, it's up to you, door sine square. So what happened here, Kirana?
1.
1 plus
Cotangent.
Very good. Don't forget the square, and then 1 over sine.
Cosecant.
Don't forget the square. Now, door what?
Huh?
Door, the third one. Come on, quickly. Door divided by
Divide what?
cosine square lah. 1 is divided by sine square. 1 is divided by cosine square. Understand?
Yeah.
Okay. Sine divided by cosine.
Tangent.
Don't forget the square plus
1.
equals to
Cosine.
1 over cosine.
Second
Don't forget the
square.
gun. Understand?
Yeah.
Good. People, are you okay? Now, one last time, I erase, you erase. Remember, you have to erase your working. Please don't look at it. There's no point in looking at your working if you're trying to memorize. Erase and then redo. Okay. When you're done, please thumbs up. As quickly as possible. Huh. I expect somebody to be ready. Nobody. Good, Evan. Good. Good, Anu. Ariel, can I finish up? Good, Ariel. Okay, just to check your working, right? Don't forget the connection. It will be valuable in real exam questions. Don't forget. Okay. Okay. Do check and hopefully you're correct. If not, just fix it. Okay. Just fix memorization. So I hope you're well acquainted with section A. This is called a section A because they are all connected now. Section A, A1, A2, A3. Now here's section B. I will immediately not bother about the tangent. The reason is very simple. When you need tangent A plus B, it's very obvious one. Not sure why. Sometimes sine A and cosine, sine A plus B, cosine A plus B, sometimes people don't realize, some people are not comfortable. Okay, so, but as a good news, this is usually the part where people are most comfortable memorizing. I don't know why, but let's just memorize lah. Okay, don't worry too much, right? Section A, section B. Look, it goes like this. Sine A plus B. And then there's also a cosine A plus B. Okay, sine A plus B is sine A cosine B plus cosine A sine B. I want you to write down this way lah, in shortcut. And then if it is minus, it is also minus. Do it that way. Cosine A plus B is cosine A cosine B is pure memorization minus sine A sine B is pure memorization. If it is minus, this one is plus. Do it this way. Is everybody clear? Try to do this yourself. When you're done, please thumbs up, and then we're going to erase do. That's it. Okay, again, get used to the shorthand form. Very fast, very flexible, very useful later. Anu and Ariel, are you done writing this for the first time? Good. Good, Kirana. Eben, Ariel, writing this for the first time. Good. Eben, you okay? Okay, Eben, for a person who have just seen this, you're doing very well. Why? You're accepting as memorization. Everybody should. Now, erase, please. Erase. And then do. I will like a bit. Remember, sine A plus B. Cosine A plus B equals to sine A cosine B plus cosine A sine B. If it is negative, negative. Cosine A plus B, cosine A cosine B minus sine A sine B. Don't forget the minus. If minus, this is plus. Whoever is done, please thumbs up. You shouldn't be slower than me, man. Good, Anu. Good, Eben. Ariel and Kirana. Good, Ariel. Kirana. Good. Erase one last time and do one last time. I told you this is kind of easy.
For
Yes.
the B part 2, the cosine one,
Yes.
there's like the plus minus sign thing, right? But it's a bit like
Reverse. It's
yeah.
reverse. Precisely. When it is cosine A plus B, you must write down as cosine A cosine B, right? Minus sine A sine B. That's what it means. Do you understand? The minus is reverse. If this is plus, this is minus. This is minus, this is plus. Do you understand, Evan?
Oh, what's the difference between putting it the normal way? Like
If it is the normal way, which is the first guy, right? Sine A plus B, right? When you have sine A plus B, you have, sine A cosine B, right? Plus cosine A sine B. Different, right? If this is plus, this is plus. If this is minus, it is different. Memorization.
Okay.
Clear?
Yeah.
Good. Okay. So you're erasing it one last time and then you're redoing it. So I'm just going to just ask you to check sine A plus B equals to sine A cosine B plus cosine A sine B minus. Cosine A plus B equals to cosine A cosine B minus sine A sine B minus plus. Okay. Anu and Ariel, did you get it all correct? Good. Good. Eben and Kirana, did you finally get it correct? Good. Again, Eben, good job, yeah? Good job. You are ready to use it. Do you know how to use it? Maybe not. Maybe you need practice. But turns out we need some preparation putting it in our mind. This is now in your mind. You will not suffer any slack or any resistance to it already, especially when teacher use it. If you never accept this in your mind will be divided. Okay, you will feel this to be a very weird thing, but now no longer. At least I hope so lah. You can later on concentrate on how to use it. So good for you. Now, section C. I am describing the connection between section B and section C. I'm describing the connection. Again, I'll just ignore the tangent one. Section C is simply section B. Why am I describing you this connection? Because they will exploit this connection in exam. Doesn't seem to be apparent here, right? So sine 2a, right? That's how we write down sine 2a is sine A plus A. And at this point, this is section B already, correct or not? This is already section B. From section C, we are immediately in section B. And all I have to do is apply SA cosine A plus cosine A sine A, which, if you notice, they are the same. Therefore, 2 sine A cosine A. There you go. Anu, do you understand what I'm saying?
Yes.
Kirana, do you understand?
Yeah, I'm still writing it down.
Go ahead. Ariel and Eben, do you understand? I'm revealing to you the connection. Good.
Can you repeat one more time?
No problem. Do you notice that I converted sine to A into sine A plus A, which is now a section B thingy?
Oh, okay.
You notice? And immediately I just use my section B. Do you understand? That's all I did. I used the one on top. That's all. Do you understand, Eben? You must see the connection with the section B lah. You must lah. That's the point.
How do you know sine 2a equals sine A plus B?
Not A plus B, A plus A. A plus A.
Oh, okay.
Which is in the format of section B, which is.
Oh, okay. Yeah, I got it.
Make sense?
Okay.
Makes sense.
Yeah.
Okay. Again, this is an attempt to make you feel like, oh, all this makes some sense. It does lah. It does make some sense. Okay. We are not just doing pure memorization. Later on, this will be exploited by the questions also. I'll show you later. Okay. Oh, no. In fact, I have to show you now. Now, I'm going to show you what the question usually do. The question will give you something like this. Sine 3a And then some people will immediately say die. This is not in identities. This is neither section B nor section C, never mind section A. Die. How are we supposed to deal with sign 3A? Ariel, any idea? Ariel?
No.
Okay. Now Ariel, don't die. Everybody, don't die. It's very easy to handle sign 3A because you have the experience of handling sign 2A. You handle sign 2A, you can handle sign 3A. This is just sign in short form 2A plus A, which is now a section B thingy. Ariel, do you understand?
No.
What are you talking about? Is 2A plus A equals to 3A?
Yeah.
Therefore, sine 3A is sine 2A plus A. That much you can accept.
Yeah.
Isn't that in the format of section B?
But why would that help?
Because you can apply section B.
Oh, okay.
Get used to this by writing it down. Get used to it. This is in general how you handle 3A and it will bear some fruit. Okay, it doesn't stop here, but this should be a good start. People get used to it by writing this down. Where does this end? Where does this lead to? Not today's business. Today's business is just to make you comfortable with identities. It is not done yet here, but it is a very good start. Most of the time, identities is the first step, you see. So, the next step, you'll think about it again. Okay, Anu, Eben, Kirana, are you okay with sign 3A? Good. Now, what about sign 4A? This also happens. Do we die? Don't die. Don't die. You have two options. Sine 2A plus 2A, which is section B method. Or sine 2 times 2A, which is section C method. You can now apply either section B or section C directly. Doesn't matter too much one. What matters is that you feel comfortable applying it. So check it out. This will be sine 2A, cosine 2A, plus cosine 2A, sine 2A. Notice that they are the same thing. Therefore, 2 sine 2A, cosine, 2 sine 2A, cosine 2A. I shouldn't be using the bracket. I'm so sorry. 2 sine 2A, cosine 2A. I applied section B. Anu and Ariel, do you understand?
Yeah.
Okay, good Ariel. Anu, good. Eben, Kirana, you okay?
Yeah.
Okay. Not that the question will stop here, but this is a very
Sorry.
useful first step. Yes, Eben? You okay?
Oh yeah, yeah.
Now I'm applying section C, which means I'm looking at this one, right? I'm looking at this immediately. Section C1, right? C1. Hey, this is B1, B2. Am I talking about this B1, B2? C1. Oh, what do you do? Oh, sine for A is simply sine 2 times 2A. So therefore, I just write down 2 sine 2A. I'm so sorry. Should be using a shortcut. Sine 2A cosine A. And then that's it. Look. To some people, this is preferable. To some other people, the section B is preferable. Whichever you fancy. Whichever you fancy. Doesn't matter. They're connected. Anu and Ariel, do you understand?
Yeah.
Eben and Kirana, do you get it?
Yeah.
Now, let's start again. We are going to erase and redo, right? So what do we erase and redo? Erase everything here. Okay. Sine 2a is the object of section C. Do this as sine a plus a equals to sine a cosine a plus cosine a sine a equals to 2 sine a cosine a. Please write this down, get used to it, and then do sine 3a and do sine 4a. Okay, to get used to it. Okay, do it by yourself. Anu and Ariel, are you done? Okay, then whoever's interested, just check it out with me. Sine to a plus cosine to a, sine a, and we stop here. Sine 4a is sine to a plus 2a. I'll do the section B method equals to sine to a cosine to a plus cosine to a sine to a equals to 2 sine to a cosine to a. Eben and Kirana, do you get this correct?
Yeah.
Yeah.
Good. Good. Anu and Ariel, did you get this correct?
Yeah.
Good. Now, the last thing is this guy. Now I'll tell you something. This is the most popular one, and this one also. These two. We open and we close with the most popular one, and they have a lot of flips, turns, and application. You have to be flexible. Because you are fast and you're using shortcut, you are preparing to be flexible. Now, your test of flexibility is in the last one. We're going to spend all our remaining 10 marks at 10 minutes in this last one. This is a real test of flexibility. But after that, you should feel extremely comfortable, at least not worried about this thing. That is at least the hope. Now, I need a different page. Now, this is specially for C2. You must start with memorization first. Cosine to A, right? That's the object of section C. Sine to A or cosine to A equals to cosine square minus sine square equals to 2 cosine square minus 1 equals to 1 minus 2 sine square. Immediately memorize that. Just immediately. Please do. We'll erase, rewrite, erase, rewrite. If you have done writing this in the short form, write down one more time. Again, follow me, everybody. Cosine to A is equals to cosine square A minus sine square A equals to 2 cosine square A minus 1 equals to 1 minus 2 sine square A. My pronunciation or my saying is as fast as my writing. That's the goal. Anu and Ariel, have you memorized this? Eben and Kirana, have you memorized this? Yes, Eben.
Mm. So this one doesn't have like any link, like.
Oh, there will. There is a lot of link, but I am asking you to memorize first. It's just easy.
Okay.
The link is there to help you accept better lah, but memorize first. Kirana, are you done memorizing?
Yeah.
Okay. Anu and Ariel, are you done? Well, first memorizing lah.
Yeah.
Anu, yeah. Okay, erase everything. Write down the 4 things. I'll be a little bit lagging. Again, for those of you watching in recording, please make sure you're doing this. There is no point not doing it. There's no point watching. This will immediately benefit you the moment you start school. I think your teacher will be a bit anxious to cover all this, but you're ready to use it. As a bonus, you're ready for the confusing impossible integration, right? The confusing impossible trigo integration. That's the other bonus. Okay, come people, cosine 2a equals to cosine square minus sine square equals to 2 cosine square minus 1 equals to 1 minus 2 sine square a. Anu and Ariel, did you get it right?
Yeah.
Good. Eben and Kirana?
Yeah.
Yes.
Anu, you okay? You sure? Anu, are you okay?
Yeah.
Okay, good. Now erase one more time. Redo it again. Then you'll feel very, very happy. Okay. Okay, people. So cosine 2a equals to cosine square minus sine square equals to 2 cosine square. I am so sorry. Minus 1 equals to 1 minus 2 sine square. Right? Doesn't matter how, doesn't matter why, you are comfortable. Now, let me show you some links. The links is from section B, of course, right? This is cosine A plus A, which is immediately a section B thingy. And this will become cosine A minus sine A, which is cosine square minus sine square A lah. Do you understand? Anu, Ariel, Eben, Kirana. That's where it comes from lah. Okay, good. Now, let me show you the connection further. Right? So, I'm using the first identity. Hey, section A, man. Now section A. Section A. In section A, you have sine square plus cosine square equals to 1, which means I can, if I want to, sine square equals to 1 minus cosine square if I want to. Applying it here, applying it there, I have now cosine square minus 1 minus cosine square equals to cosine square minus 1 plus cosine square equals to 2 cosine square minus 1. There you go. Anu and Ariel, do you see the connection? It's not that the connection is important, but connection is nice, makes you feel better. It's not that you have to memorize them, but you are training to be flexible. Eben and Kirana, do you see it?
Yeah.
Good. Now the final connection, which is here, right? Also a section A thingy. Section A, which is sine square plus cosine square equals to 1. Look at how comfortable I am simply repeating it. That's what you need. Cosine square equals to 1 minus sine square. So what happened? This will become 1 minus sine square minus sine square, which of course is 1 minus 2 sine square. Done. Can you see the connection? Anu and Kirana. Okay, so we're happy with all this, right? All this stuff. That's great. Now let's make it smaller. I still have one more connection to drill to you. This last connection is very widely used in exam, and I've seen people feel very uncomfortable with it. Same problem one. They feel uncomfortable. Let's not feel uncomfortable. Last connection, right? We're still talking about the same thing. We're still talking about cosine 2a equals to cosine square minus sine square equals to 2 cosine square minus 1 equals to 1 minus 2 sine square. We're still talking about this guy. What do we do? The connection between this guy. Look, yeah, look. Now, we can say that cosine 2a equals to 2 cosine square a minus 1. We can say that. Now, we have a very big interest in, I'm so sorry, We have a very big interest in this guy. And we want to make this guy on the right-hand side, yeah? We want to make this guy alone. Want to do that. Now observe how I do it. I take the left-hand side, cosine to A. I see a +1 here, right? -1 here, right? So I must +1. I see a 2 here, right? So I must divide by 2. I see a square here, right? So I must square root with a plus minus, don't forget. And this is now equals to the aforementioned cosine. I want you to do this not step by step. I want you to do this with your mind immediately. Snap, snap, snap. People who can do this tend to waste 2 minutes doing this in exam or just get fully confused. Either one is not good. I want you to be able to do this at one go. Snap, snap, snap. Any questions so far? Anu?
No.
Ariel? Eben and Kirana, do you understand what just happened?
Not really.
Come on, Eben. Follow me, yeah? Follow me.
Yeah. Yeah.
Cosine to A plus 1 equals to 2 cosine square. Correct or not? -1 plus 1, correct?
Yeah.
Cosine to A plus 1 divided by 2 because, 2 correct?
Uh-huh.
Then finally square root of everything lah. Cosine to A minus 1 plus 2
Oh,
equals to cosine, but with a plus minus. I do not want you to do this step by step. I mean, you are an expert in math. You're taking A math, everybody of you. Do not do this step by step. Please do it in your mind. Understand, Eben?
yeah.
Do not do this step by step. I implore you, please practice with your mind. Do it step by step, but in a way like this. Let me show you one more time. This is what I want you to do. I want you to not do it randomly. I want you to think carefully. Cosine to A, I need to plus 1 first. Okay, and then I need to divide by 2 first. And then I need to square root first. We'll forget the plus minus equals to cosine. I want you to do it step by step, but this way, not write down everything. Okay? Anu and Ariel, Eben and Kirana, please do this. Yes, Eben?
And this is just for...
This is not for fun. This is totally exploited by them in exam. Totally. I am promising you, this is like one of the most useful thing today. I promise you first. If you can do this, just so good. This is my promise, okay? Okay, let's erase again, people. Erase, you do, I'll like a bit. Okay, remember, start with cosine to A plus 1 divided by 2 square root plus minus equals to cosine. I am looking at it. I'm not actually memorizing this. I am training my flexibility. Erase it one last time. Erase it, people, one last time. This is where iPad shines. This is where iPad shines. At least. Thanks a lot. Cosine to A, watch it. I need plus 1. Watch it. I need divide by 2. Watch it. I need square root. Anu and Ariel, did you get it correct? Good.
I think so, yeah.
Eben and Kirana?
Yeah.
Good.
Yeah.
Last one. Last one. Last flexibility, which I guarantee you is not just for training purposes. This is like totally usable in exam. I am connecting between this and that. I'm sorry, there isn't supposed to be an arrow. This is not a change. Okay. Second connection, still very similar, but exploiting the other one. Now, because of the minus, it'll be a little bit confusing. Watch me, watch, please, watch. First, I take care of the 1, which is to say cosine to A minus 1. I hope that's not a problem. Secondly, I am taking care of the minus, which means minus and plus. Do not try to rewrite this to 1 minus 2 cosine A. It's useless. It's a waste of time. It's confusing. It's much better to just minus and plus. At this point, if you are confused, please tell me. Because the rest is just divide by 2 and then square root, same thing, equals to sine. Okay. Some people struggle with this a lot before exam. You don't have to struggle. You don't have to. It's not difficult at all. One more time, let me repeat this for you. People who are watching recording, do this, yeah, repeat, yeah, don't just see. I have cosine to A. My goal is an isolated sign. I see a 1, I minus 1. I see a minus, I put minus, I put plus. The easiest way ever. I see 2, divide by 2. I see square root, don't forget the plus minus equal to sign. Anu and Ariel, do you understand?
Yes.
Good. Eben and Kirana?
Yeah.
Okay, go, erase and rewrite. Don't forget to erase first. Have confidence. Erase first. Okay, people, one more time. Cosine to A. I see a 1, minus 1. I see a minus, minus, and plus. I see over 2 simple square root plus minus equals to sine. People, let me warn you. You can do this, right? You can do this. Some people choose to memorize. Look, there is a very small difference between this guy and that guy. Let's compare that one. The only difference is this guy. Do you notice that? The only difference is the minus. That is the sole difference. Some people therefore think it is very easy to memorize. It's totally the opposite. It is extremely difficult to memorize. Do not memorize this. The practice of deriving, going from here to here, is already something good for you, flexible. So you should do it. Whenever you're preparing for exam, you should just practice deriving. It's just way faster than memorizing, because memorizing something that is so similar is a bit suicidal if you have to handle a lot of things at the same time. Just have to memorize this one thing for the exam tomorrow. I don't mind. That's not true at all. Heed my warning. Do not memorize this. Derive it. It's good for flexibility. I hope you understand this. Erase it one more time and do it one more time. Have confidence. Go, go, go. So cosine to A, minus 1. The minus doesn't matter. Minus plus divided by 2 square root plus minus equals to sine. Anu and Ariel, did you get it correct? Good. Ariel?
Yeah.
Eben and Kirana?
Yeah.
Yeah.
Okay. Now, I'm asking you 3 more minutes. We're going to summarize from the start to the end. There'll be the closing. Okay, 3 more minutes, people. Stay with me. We're going to rewrite everything, right? So I'll show you section A. You go and write section A. New page, please. Sine square plus cosine square equals to minus 1. Door divided by sine square. You have 1 equals plus cotangent square equals to cosecant square. You go and write this down. Divided by cosine square, you have tangent square plus 1 equals to secant square. If you can do this, you deserve to be proud. Anu and Ariel, are you done?
Yes.
Good. Good. Eben and Kirana, are you done?
Yeah.
Yeah.
You're fast and hopefully you're flexible. The connection itself is already helping. Section B, there's only two things. We're ignoring the tangent. Go. Section A plus sine A plus B equals to sine A cosine B plus cosine A sine B minus. Cosine A plus B is cosine A cosine B minus sine A sine B minus plus. Anu and Ariel, are you correct?
Yes. Wait. The top one is if like the one on the left is minus, then the one on the right is plus, and then the bottom is the opposite, right?
Yes, correct.
Okay.
You have to memorize that. Eben and Kirana, are you correct?
Yeah.
Yeah.
Good. Now section C, right? Sine 2A. Do the connection sine A plus A equals to sine A cosine A plus cosine A sine A equals to 2 sine A cosine A. Do the connection, it will be helpful for other things. Now, for the cosine 2A, just immediately memorize everything, right? Cosine square minus sine square equals to 2 cosine square minus 1 equals to 1 minus 2 sine square. Are we done so far? Anu and Ariel? Eben and Kirana?
Yeah.
Yes.
Last one. This one. Most of the connections I don't write here just to make you happy, right? But certain things that we write, for example, this one. Look at that. Cosine 2A equals to that. Immediately, what do? Cosine 2A, you look at it, oh, plus 1. You look at it, oh, divide by 2. Square root plus minus equals to cosine. Can you do that? The other one. There isn't supposed to be an arrow here. Right, the other one. Look. Oh, cosine 2A. Oh, minus 1. Oh, there's a minus plus over 2. Square root plus minus equals to sine. Right side. Anu and Ariel, you okay?
Yes.
Eben and Kirana, you okay?
Yeah.
Yeah.
Good. Now, thank you for your time. Just to communicate with you, yeah. This is a simple preparation before anything, including before exam. This is less than 3 minutes. When you can do this, you feel that you're ready for the question. Even right now, when you haven't practiced much, you feel ready. It's not ready, but you feel ready to use them. That's very important. In less than 3 minutes, you can convince yourself you're not going to have that much of a trouble. Just a little bit. Okay? Now, especially for you, Ariel, you were very, very unhappy with this part back then. How do you feel right now? Ariel?
Sorry. I don't know if I'll actually be able to apply it.
Of course not. You haven't practiced, but you're ready to at least use it. Okay?
Yeah.
At least you are not worried. Now for you, Eben, good job, yeah. For a person who have not seen this before, if you can do this, then hopefully you'll be ready for your school. Now, everybody else except Ariel, congratulations. The amath is officially finished. Tomorrow we'll settle some other things. Tomorrow is really the last day. Attend if you can, please. It will be useful. If not, don't worry too much about it. That's the design of the holiday tuition. Attend more, get more. Attend minimum, it's gonna be fine, totally fine. Good job, everybody. Besides Ariel, please stay.
Thank you.
Okay. All right.
Thank you.
All right. Okay, Ariel, I'll just stop the